Okay, this is number 14 from 8-6. Okay, so it's number 14. So it tells us we've got x to the fourth minus x plus 3 is equal to 0. Okay, so these are all about using Descartes rule. Okay, so let's look at this. P of x. P of x is x to the fourth minus x plus 3. Okay, so P of x talks about positive real numbers. So we look at the number of sign changes. There are 2 sign changes. So that means we have 2 or 0 positive real roots. P of negative x let's do negative x. P of negative x makes it negative x to the fourth minus a negative x plus 3. So that makes it x to the fourth plus x plus 3. So in this particular case, P of negative x talks about negative real numbers. Okay, and since we go positive, 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 there are 0 sign changes. Okay, so that means there are 0 negative real roots. So what we have is we have an option of real roots. Okay, we can have positive real roots or negative real roots, or we can have imaginary. Okay, so our options. Our options are 2 and 0, 2, 0, or 0 and 0, 0, 0. Now, because our degree is 4, that means we need 4 roots. Currently, here I have 2 positive, 0 negative, so I need another 2 imaginary. And here I have 0 positive, 0 negative, so I need another 4 imaginary. Okay, so that's number 14. I'll take a look at a couple more. Okay, this is still 8-6, and this is number 16. Alright, it's x to the fourth minus 3x cubed plus 5x squared minus 2x plus 5 is equal to 0. Alright, so let's take a look at P of x. P of x is the original, x to the fourth minus 3x cubed plus 5x squared minus 2x plus 5. Now P of x deals with positive real. So if you look for the number of sign changes, and we've got a lot here. We've got 4 sign changes. So 4, 2, or 0. Alright, now let's look at P of negative x. Okay, I'm going to skip a step here and just remind you that if it is an even exponent, the sign will not change. If it's a negative exponent, the sign, or an odd exponent, the sign will change. So if I plug in a negative x, I'll end up with that. Okay, and remember, this deals with negative real numbers. So in this case, there are 0 sign changes. So let's make our table. We have real answers, we have imaginary answers, and in particular, we have positive or negative real versus imaginary. Okay, well, our life's easy, less combinations. I can have 4 and 0, 2 and 0, 0 and 0. Let's list those out. 4 and 0, 2 and 0, 0 and 0. And since my degree is 4, I need 4 roots. So if I fill that out, I've got 4 here, 0 here, so that gives me 0 there. 2 here, 0 here, so I need 2 there. And then if I've got 0, 0, so I need 0 there. Alright, now it's still Descartes' rule. That means we could have 4, we could have 4, 0, or 0. Alright, we could have 2, 0, 2, or 0, 0, 0. Alright, so let's take a look at another one. Okay, this is 8.6, number 18. Okay, 8.6, number 18 says x to the 5th minus x to the 4th plus 2x minus 3 is equal to 0. So let's look at p of x. P of x is the original, x to the 5th minus x to the 4th plus 2x minus 3. Okay, and so remember, p of x deals with positive real roots. Look for the number of sign changes. We have 3 sign changes, so it's 3 or 1 positive real roots, because it's got to be an even integer or less. Alright, and then look at p of negative x, so that's negative x to the 5th minus x to the 4th minus 2x minus 3. Okay, so remember, p of negative x deals with negative real. Okay, and then in this case there are 0 solutions. So I have real, positive or negative. I also have imaginary. So I can have 3 real, 3 positive real, 0 negative real. I could have 1 positive real, 0 negative real. And since my degree is 5, I need 5 roots. Okay, so if I've got 3 plus 0 is 3, I need 2 more that are imaginary. And I have 1 plus 0 is 1, so I need 4 more here that are imaginary. So that's Descartes' rule. There's 3 more examples for you. Try yours to match along with this. Alright, this is still 8.6, and in this case we're looking at number 22, which is like number 21 you have in your homework. We want to find a 4th degree, so n is equal to 4, polynomial with integral coefficients or integer coefficients. So it tells me I have 1 plus I and 1 minus I as my roots. Okay, well, that means I have 1 minus I. Oh, sorry, not 1. Those are wrong. That's not right. I misread. It's 1 plus I and 2 plus I. Okay, so that means those are also roots. So I have my 4 roots. My 4 roots being x is equal to 1 plus I, x is equal to 1 minus I, x is equal to 2 plus I, x is equal to 2 minus I. So all of these create factors. X minus 1 plus I, x minus 2 minus I, x minus 2 plus I. Those are all factors. Remember, we multiply those to get 0. So there's a couple different ways we can treat this. Remember, I'm going to treat that as a difference of squares. So at x minus 1 minus I, x minus 1 plus I. I'm going to treat that. Okay, so if I do that, I get x minus 1 squared minus I squared. Okay, and I do the same thing over here with x minus 2, I get x minus 2 squared minus I squared. Okay, that's equal to 0. Okay, so that's x squared minus 2x plus 1 minus a negative 1 or plus 1. That's x squared minus 4x plus 4 plus 1 is equal to 0. Alright, so x squared minus 2x plus 2, x squared minus 4x plus 5 is equal to 0. Alright, so let's go from there. We got to FOIL this out. So x to the 4th, I've got negative 4x squared, negative 4x squared, negative 4x cubed, negative 2x cubed gives me negative 6x cubed. Let's look at x squared terms. X squared, 2x squared, okay, 5x squared, and 8x squared. 2, 5, and 8 gives me 15x squared. Let's look at x terms. Okay, negative 2x times 5 is negative 10x. 2 times negative 4x is negative 8x. So I'll get negative 18x. And I've got 2 and 5 gives me 10. Alright, and there is your answer. That's a polynomial, fourth degree polynomial with integral coefficients with these given roots, which means this is a root and this is a root. So here's your answer. Okay, this is 8.7. Okay, this is number 8. Okay, so this is like number 7, 9, 11, and so on. That's 2x cubed minus 5x squared minus 11x minus 4 is equal to 0. Okay, we want to list the possible rational roots and solve. So I look at p and q, my constant. Okay, the constant is equal to negative 4. Leading coefficient is equal to 2. So look at my factors of each. That's positive negative 1, positive negative 2, positive negative 4, positive negative 1, positive negative 2. Now I want the ratio, or the division of the constant over the leading coefficient. So that means I get positive negative 1 over 1, positive negative 2 over 1, positive negative 4 over 1, versus positive negative 1 over 2, positive negative 2 over 2, positive negative 4 over 2. Some of these things are repeats. For instance, 2 over 2 is the same thing as 1 over 2, so it goes away, or 1 over 1. And 4 over 2 is the same thing as 2 over 1, so it goes away also. So I have 8 possible roots. Now I need to see if one works. Multiple ways to do this. You can synthetic divide. Okay, so you get 2, negative 5, negative 11, negative 4, and you synthetic divide until one works. Okay, in this case I get 2, 2, negative 3, negative 3, negative 14, negative 14, negative 18. So 1 doesn't work. Negative 1, 2, negative 5, negative 11, negative 4. And when I try that, I get 2, negative 7, 7, negative 4, positive 4, 0. That works. Excellent. That means negative 1 is a root. Okay, so x equals negative 1. I also know from this that 2x squared minus 7x minus 4 is equal to 0, which is factorable. So I factor it, and I get 4, 1, I want negative 8 positive. So that gives me an outside 2x squared, negative 8x plus x gives me the negative 7x, 1 and negative 4 gives me the negative 4. So I get 2x plus 1 is equal to 0, x minus 4 is equal to 0, 2x equals negative 1, x equals negative 1/2, x equals 4. So my solutions are, and including the one already found, x equals negative 1. Those are my solutions. Okay, do one more in regards to 8.7. This is 8.7, number 12 is what I'll do. Okay, so it's 6x to the 4th. Good, means I need 4 solutions. 6x cubed plus 8x squared minus 7x plus 2 is equal to 0. Okay, so again, we want the constant. Okay, so my constant is 2. I want my leading coefficient. It's 6. I want the factors of those. Positive negative 1, positive negative 2. Positive negative 1, positive negative 2, positive negative 3, positive negative 6. Okay, so that gives me those. Now, I've got my possibilities. Constant factors over leading coefficient factors. Okay, kind of ran out of space here. I like to be a little bit more systematic with it, but because I ran out of space here on the side, I'll do it like that. Throw out anything that repeats. 2 over 2 is the same thing as 1 over 1. 2 over 6 is the same thing as 1 over 3. So we got 2, 4, 6, 8, 10, 12 possible solutions. 2 here, 2 here, 2 here, 2 here, 2 here, and 2 here. So we try them. Okay. The other way to try them is you can just plug them into your calculator. For instance, you could do 6 times 1 to the 4th minus 7 times 1 cubed plus 8 times 1 minus 7 times 1 plus 2, and you're checking to see does it equal 0. In this case, you get 6 minus 7 plus 8 minus 7 plus 2. And in this case, that equals what? Negative 14 and positive 16, that equals positive 2. So we'd throw out 1. Or you can keep synthetic dividing, negative 1. And we've got 6, negative 7, 8, negative 7, 2. Now we try that, bring down the 6. And I get negative 6, negative 13, 13, 21, negative 21, negative 28. Positive 28, so not that one. Try, I'm going to skip to 2. Alright, so let's do 2, 6, negative 7, 8, negative 7, 2. Alright, and try that one. So it's 6, 12, 5, 10, 18, 36. 2 doesn't work. Try negative 2, 6, negative 7, 8, negative 7, 2. Try that one. We just keep trying until we find one that works. Alright, and so that's 6. It's negative 12. It's negative 19. I'm pretty sure this one's not going to work. Alright, so that one doesn't work either. Okay, so we've tried what? We've tried both positive and negative 1. We've tried positive 1 here. Positive 1 here, negative 1 here, positive 2, negative 2. So I tried those. That leaves me with the fractions. Okay, and they could be anything. You just keep trying until you find one that works. Okay, and if none of them work, then there's no rational roots. Remember, these are possible rational roots. Okay, I'll try a few more. 1/2, 6, negative 7, 8, negative 7, 2. Alright, and so I get 6, 3, negative 4, negative 2, 6, 3, negative 4, negative 2, 0. Well, that one worked. 1/2 works. Okay, so we know 1/2 works. Okay, but 1/2 works, and then I end up with this expression, 6x cubed minus 4x plus 6x minus 4 is equal to 0. Luckily for us, that's x squared. That's factorable. That's factorable with, can pull out a 2x squared, so I get 2x squared plus 2, and then we get x minus 2 on the other one equals 0. And so solving each of those, I've got 1/2, I've got x is equal to 2 from that one, and then 2x squared plus 2 is equal to 0. X squared is equal to negative 1. So x is equal to positive negative I. And that comes from that one. Okay, so my solutions are x is equal to positive negative I, x equals 1/2, or x equals 2. So 1/2, 2, positive negative I. That's the 4 solutions I should have. And I've got 2 rational, 2 positive real, and then 2 imaginary solutions. Okay, let me know if you have questions.